Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Syahrul Arman bin Samsuri, and I'm from RK23 from Group 1. So, the title for my presentation is the parameters in three-phase Y-connected generator. So, moving to the introduction. So, a three-phase generator generates power in three-phase 120 degrees apart. Each phase is measured from face to face. All three phases are joined to a common point known as neutral. So, measuring the power from the center point to any of the outer points will give you a single phase power value. Example, line 1 to center point is 230 volts. A symmetric three-phase power supply systems. Three conductors each carry an alternating current of the same frequency and voltage amplitude relative to a common reference, but with a phase difference of one-third the period. Uh, due to the Due to the phase difference, the voltage on any conductor reaches its peak at one-third of a cycle after one of the other conductors and one-third of a cycle before the remaining conductor. This phase delay gives constant power transfer to a balanced linear load. We explored the idea of three-phase power system by connecting three-phase voltage sources together in what is commonly known as a Y configuration. So this is the circuit of Y connected, and delta is the delta. So the three conductors leading away from the voltage source towards a load are typically called line, while the windings themselves are typically called phase. In a Y-connected system, there may or may not be a neutral wire attached at the junction point in the middle, although it certainly helps alleviate potential problems should one element of a three-phase load fail open. Uh, So moving to the objective, so we have three objectives. So the first objective is to investigate and analyze an electrical system that consists of a three-phase Y-connected generator. The second is the evaluate the parameters of the electrical system in the context of transmission and loads, impedance, currents, voltage, and acceptable voltage drop based on BS7671 or any Malaysia's authority standard. And the third, which is the last objective, is to evaluate and analyze the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. Moving to the methodology, so we have to construct a Y circuit and then put the line voltage value, which is every student got the random value, which is they have their own value, and the next is put the load and transmission loss value after convert the unit for inductor, and measure and record the parameters. So this is for my circuit that I draw. A three-phase Y-to-Y connected circuit was this is a three-phase Y-to-Y connected circuit, and applied the impedance value and the V line to line, which is given in the appendix, which is all students got the difference value. So for the calculation, and results. So my V line to line value is 132 kilovolts. So I use this formula and got the value for VV, which is 76.31 kilovolt. And I got for the VN, I got the VAN for 0 degree, VBN I got negative 120, VCN I got positive 120 degree volt. So since Z1 equals to Z2 equals to Z3, so IN is equal to 0. So IN, I could use this formula BAN over ZT, the total. So I got 534.03 ampere and negative 8.87 degree. And for IBN, I got same value, but for the angle is negative 120.87 degree. And for the ICN, I got the angle is 111.13 degree. So IL is equal to IV, so IAA equals to IN, which is same value as that I told you at here. So for the phase load, so V load A equals to IN equals multiplied by Z1. So for the V load A, I got 43.522 kilo angle 6.34 degree volt. And for the V load B, I got uh, same same value, and but the angle is negative 126.34 degree volt. And for the V load C, I got the angle is 113.66 degree volt. For the active power, I use this formula PA equals to VAN multiplied by IAA and multiplied by cos theta. So for the value for the PA, I got 22.428 megawatt, and I use this formula PT equal to PA times 3. So PT equals to 67.284 megawatt. For the voltage drops, I got I use this formula V supply minus V load divide by V supply and multiply by 100, and I got 42.89%. So this is the result that I got from the PCIM software. For this is the graph I got for the voltage line to line, which is got a huge difference, but this is what I got. uh, the value that I calculate is the value that I was given is 132, but the value that I got from the PCIM is 106, which is a huge difference. So moving to the current line I got from the PCIM is 534.07, which is just slightly different with the calculate, which is 534.0803. Sorry. And okay, for the phase voltage, I got 43.525 kilovolt compared to the calculate value, which is 43.522 kilovolt, which is just a bit different, near to the calculate value. So next, for the power absorbed, which is the 2 wattmeter method, I got 68.929 megawatt, and compared to the calculate value, which is 67.284 megawatt. still it's near, but it's not close enough. So, and this one is for the power absorb value by conventional method, and I got 68.93 compared to the measured value, which is 67.284. That's for the calculation and results. So moving to the discussion. Okay. For the discussion from the result of this project, at the end of this project, students discuss about the relationship, line voltage, line current, and phase load and active power absorbed of three-phase Y-connected generator. In Y configuration, line current and phase current are same but not for line voltage and phase voltage, where in Y to Y connection, phase voltage is 0.577 times line voltage. So for line voltage, the theoretical value is 132 kilovolt, but the value that I obtained from the simulation is 106 kilovolt, which is a huge difference. So line current and line phase are same. Student only measured the line current value. The calculated and measured value has a very slightly different, which is 534.03 ampere and 534.07 ampere respectively. For value of active power absorbed are measured into the value of active power absorbed are measured in two ways, which is 2 watt method and conventional metering method. And the reading is for the 2 watt meter method, I got 68.929 megawatt, and for the conventional metering method is 68.93 megawatt. Right. So moving to the conclusion, Y configuration is used to distribute power to everyday single-phase appliances found in home and office. Since the installations is decided by phase voltage and for Y connection is 0.577 times line voltage. For delta connection, phase voltage and line voltage are equal since the installation level is decided by phase voltage, and for Y connection, phase voltage is 0.577 times line voltage, and hence installation required in Y connection is nearly 57.7%, where can be used for high voltage generation than the installation that will be required in delta configuration for same line voltage, and hence cost for installation will be reduced. So the three-phase connected generator is in electrical system has been analyzed, and all the parameters of Y connection in the context of transmission and load impedance, currents, voltage drop have been evaluated. We also able to evaluate the power absorbed by using 2 watt meter method and the conventional measuring method. This experiment had been validated by with simulation of Y connection. So that's all from me. Thank you and have a pleasant day.